First, let's look at Appendix E, solving compound inequalities. So when solving compound inequalities, sometimes you can see the word either and or in between the inequalities. And let's talk about what the difference is between those two. So for and, you would either see the word and this is the same thing as writing A intersection B. So this is a graphical way to see what this means with an inequality. And when we're looking at the intersection, let's say I have set A and set B. So this is A and this is B. The intersection, or the word and, says what do these two sets have in common? And that would be this little piece in the middle. Now if you see the word or, this is saying what is the union of the two sets, A union B. So again, if I had set A and set B, what I'm looking for is not what they have in common, but everything that is in set A and set B. So they don't have to have it in common. So this would be everything in set A and set B. So that's the difference between and or. Okay, so let's look at this when solving. Here we go. So before we actually solve, we're going to look at the inequalities. So this is a solution, how to graph it, and then how to write your answer in interval notation. And then we'll actually get to solving inequalities. So the first inequality, let's say it's solved and you get x is in between -2 and 5. First, let me move this up a little. Okay, so the graph of this, first thing I'm going to do is draw the number line, and I'm just going to plot those two numbers, -2 and 5, and make sure they go in order. So I have to start from -infinity across to infinity. So your negative number should come first, and then the 5. And I don't have to label everything in between, I just need to label those 2 points. And then this says x is greater than -2 and less than 5, so not equal to, just greater than and less than. The equal sign, I'm going to have to actually add these in, and some of these it's missing, would be like down below here. So I'll show you that in a minute. So when it's not equal to, you're just going to use a parentheses to show it's in between these two numbers, but doesn't actually equal the -2 or 5. And then the way you would write this in interval notation is reading your number line from left to right. So this says parentheses, -2, comma, 5, parentheses. So this is not a point. This is saying my solution is all numbers in between -2 and 5, but not including those two numbers. Now for this one, let's actually add in an equal sign under these. So it's going to be the same inequality, except we're going to have it be an equal sign. And so I'm going to draw my number line. I'm going to plot the -2 and 5, just like we did before. And the only difference here now is that instead of a parentheses, I'm going to use a bracket to show that the solution actually does include -2 and 5. So this is all numbers between -2 and 5, including those two numbers. So writing this, it would be bracket -2 to 5 bracket. And then the other thing is that you can have a mixture. So let's say it's -2, and then we'll put the x is greater than -2 and less than or equal to 5. So I'm going to put my number line. I'm going to plot -2 and 5. And in this case, we're going to have a parentheses at -2 and a bracket at 5. And it's all numbers in between there. So highlight there. So this would be parentheses -2 to 5 bracket. Okay, now I actually want to cross this one out and show you something a little bit different. Let's say we're going to do x is greater than or equal to 1. So we'll do some with a little more complication, but I just want to show you this basic one when it's not in between two numbers. So I'm going to draw my number line. I'm going to find 1 on the number line, and this says x is greater than or equal to, so that should be a bracket, not a parentheses, and greater than would be going to the right. So we'll highlight all of that. Now, the way to write this in interval notation, it would be bracket 1, comma, and then you're going on to infinity in this case. If you're going to the left, you'd be going to negative infinity, but we're going to the right. So numbers are getting larger and larger, never stopping. And so that we put the infinity symbol here. And then that's not a number you can actually reach. So you always use a parentheses with infinity or negative infinity. Okay, so let's practice. Let's solve the inequality. 3x is less than or equal to 15 and 2x is greater than negative 6. So I always try and, if there's the word and or in between, I try and highlight it or circle it to remind myself what I'm looking for here. And the word and, remember, means intersection. So I'm going to need that at the end. Let's go ahead and solve these inequalities first. So just solve like an equal sign. So in this case, I'll divide both sides by 3. And I get x is less than or equal to 5. On this side, we divide both sides by 2, and you get x is greater than negative 3. So these can be much more complicated to solve. Just use the same steps as you would for an equation to solve the inequality. So the next step is we're going to draw our number line. So we can get a visual of what this looks like. And I'm going to write the numbers. Remember, from negative infinity to infinity, so I need to start with the negative 3, and then the 5 would be over here. And then let's draw this out. This says x is less than or equal to 5, so less than or equal to is a bracket, and the direction you'd be going is to the left. So I'm going to draw this above just so I can see. For and, I'm looking for their intersection, so I'm going to draw them both, and then look for what they have in common. Then x is greater than negative 3 would be a parentheses, and then greater than would be going to the right. Okay, so the solution is where these two graphs, the red and the green, what they have in common. So in this case, it would be from negative 3 over to 5. That's all they have in common. So that's my solution right there in blue. And to write that in interval notation, it would be parentheses, negative 3, 5, bracket. Okay, so let's do another example. In this case, we had the word or, so we're looking for union. So everything in the set's not just what they have in common. So let's solve each one of these separately. So on the left-hand side here, I'm going to add 5 to both sides. And I get 2x is less than negative 6. Divide both sides by 2. And we get x is less than negative 3. On the right-hand side, we're going to add 1 to both sides. We get negative 5x is greater than or equal to negative 5. Divide both sides by negative 5. And this is a good reminder when multiplying or dividing with an inequality, when multiplying or dividing by a negative in an inequality, you actually have to switch the inequality sign. So it's greater than or equal to needs to become a less than or equal to. And we get x is less than or equal to negative 5 divided by negative 5 is 1. So remember that rule, when you multiply or divide by a negative in an inequality, you need to switch the sign. Okay, so let's draw this out. Again, start with the negative 3 or the smaller number, and then the 1. And I'll start with x is less than negative 3. That would be a parentheses, and less than is going to the left. For the other, x is less than or equal to 1. It's a bracket, and less than is also going to the left. So remember, if this was end, the solution would be right here from -3 on to the left. But this is the word or. So it's basically asking what is covered on the number line. And what is covered on the number line is everything from -infinity all the way to 1. So basically what I have in red. So it's from 1 all the way over. This is my solution. And writing this in interval notation, you start left to right. So over in the left, this is an arrow going in the negative direction. So it's parentheses -infinity to we end at 1 with the bracket. So that's the solution. Okay, now let's look at Appendix F, which is absolute value equations and inequalities. So let's start with equations. And for absolute value, the absolute value of a number is basically its distance from 0 on the number line. And it's written with these two straight lines. I'll put just n in there. So that means the absolute value of n. To solve the absolute value equation, the first step is to make sure the absolute value sign is alone. So you want it by itself. You don't want anything added, subtracted to it, or multiplied or divided outside of the absolute value sign. Then you can set up your two equations to solve. So to show you why there's two equations, if I say I want the absolute value of 4, this is saying what is 4 units away from 0 on the number line. That would be both 4 and -4. Both of those numbers are 4 units away from 0 on the number line. So we're talking about distance. So you can drop that negative sign and say it's 4 units to the left, and this 4 is 4 units to the right. Okay, so when you have the absolute value of n equals some number a, so the absolute value is by itself, you would set up your two equation. It helps to kind of put these two lines to remind yourself you have two equations. So the first one would just be when is n equal to a, and the second would be when is n equal to -a. Because remember, the absolute value of -a would just be a. So those are your two equations you would be solving. Okay, so let's go ahead and solve. Absolute value of x minus 7 plus 8 equals 10. So remember, the first step, I need to get this absolute value sign by itself. So I'm going to subtract 8 from both sides. And I get the absolute value of x minus 7 equals 2. Now that I have the absolute value by itself, I can set up my two equations to solve. You can't do that beforehand. So I'm going to draw my two lines to remind myself. This is a lot of times I only see one solution. So highlight or in some way remind yourself you're always going to have two solutions. It could be the same number, but you have two equations you need to set up. So the first one here I'm going to have is x minus 7. When does that equal 2? And then I want to know when does x minus 7 equal -2. So I'm not changing the symbol inside the absolute value sign. I'm only changing the sign to the right of the equal sign. So 2 and -2. So we're going to go ahead and solve both of these. I'm going to add 7 to both sides. And here I get x equals 9. Over here I'm going to add 7. And I'm going to get x equals 5. So my two solutions are 5 and 9. And I can show you why this works. If I go up here and plug in 9, 9 minus 7 is 2. The absolute value of 2 is 2, and 2 plus 8 is 10. If I plug in 5, 5 minus 7 is -2. The absolute value of -2 is 2, and 2 plus 8 is 10. So both solutions work. Okay, this one is a little bit different than I have an absolute value sign on both sides. So there's nothing to move outside of the absolute value sign. There's nothing to add, subtract. So when you have an absolute value set equal to an absolute value, you actually go ahead and set up your two equations. And it's the same thing. You're only going to negate one side of the equal sign. So I'm going to first solve when does 2x plus 1 equal x minus 3. And then I'm going to solve when does 2x plus 1 equal the negative of that whole thing, x minus 3. So let's go over here and solve. I'm going to subtract x from both sides and subtract 1 from both sides. So I'm going to do it all in one step. Let's go ahead and simplify, and I get x equals negative 4. Over here on the right-hand side, first thing I need to do is distribute this negative sign through the parentheses. So I get 2x plus 1 equals negative x plus 3. And then I'm going to go ahead and add x to both sides and subtract 1 from both sides. And I get 3x equals 2. Divide both sides by 3, and I get x equals 2/3. Oops. That's my second solution. So our solutions are 2/3 and negative 4. Okay, we're now going to look at absolute value inequalities. Let me go back up. And I'm going to show you a different way to solve these than you're going to see in my math lab or your book. So just know if you go to help me solve this, you try and get help in the book, you're going to see a different way to solve these. But I've seen the best results when I show students how to solve using this method. So this is the way I'm going to show you. And you can use any method you want. So the first thing that you're going to do is ignore the inequality sign and solve as if you had an absolute value equation. So that means ignore the less than or greater than and solve as if you had an equal sign, getting your two solutions, just like you would if you were solving. So that's two solutions. The solutions above are called your boundary points. Okay. Graph your boundary points. On a number line. And that's why they're called boundary points, because they're going to divide your number line into different regions. So these are the boundaries of the regions. What you do now that you have your regions on your number line is you're going to test the 3 regions created and see which regions are true. So that means if you plug in a number from that region into the original absolute value, you get a true statement. Whichever region or regions are true, this is the solution. So you're going to either have one region, the solution, or 2 regions. So you can either have 1 or 2. So this are the solutions. Okay, so let's do this example. Solve and graph absolute value of 2x plus 7 is less than 11. So first up, I'm just going to ignore that inequality and solve absolute value of 2x plus 7 equals 11. So the absolute value is by itself, so I have to follow the same rules as if this was an equal sign. So now, since it's by itself, I can set up my 2 equations to solve. Either 2x plus 7 equals 11, or 2x plus 7 equals negative 11. I'm going to subtract 7 from both sides, and I'm going to get 2x equals 4. divide by 2, and I get x equals 2. So that's my first boundary point. Over here, I'm going to subtract 7 from both sides, and I get 2x equals negative 18. Divide by 2, and I get x equals negative 9. And that's negative 9. There we go. That's my second boundary point. Okay, so the way that you test these regions, let's draw a number line. Okay, I'm going to plot those 2 points. Remember, they have to be in order. So the negative 9 first, and then the 2. And this, I'll just draw the lines to show you, it's broken up this number line, pretend like that's a straight line there, into 3 regions. Okay, region 1, 2, and 3. And so what you want to do is pick a point in each region and test it and see if you get a true or false statement. So I'm going to pick the easiest point I can. So in this first region, the first point I could pick, whole number, would be negative 10. So I'm just going to go back, move this, okay, to the original absolute value inequality. So absolute value of 2, and instead of an x, I'm going to plug in that negative 10 that we're testing. And I'm trying to see, is this true? Will this number be less than 11? So do a little math. Negative 20 plus 7 is negative 13. And remember, that is the absolute value. And then the absolute value of negative 13 is 13. Is 13 less than 11? No, that's false. So that's not my region. Let's come to the middle region. The easiest point we could pick here is 0, because 0 is in between negative 9 and 2. And so this will be really easy to solve. Plug in 0 for x and solve in the original absolute value inequality. 2 times 0 is 0, and then 0 plus 7 is 7. So we have the absolute value of 7 is less than 11. The absolute value of 7 is 7, and 7 is less than 11, so this is true. And now let's test the last region. I'm going to plug in 3 into the absolute value inequality. And I have 6 plus 7 is 13. Absolute value of 13 is less than 11. We already know absolute value of 13 is 13. That is false. That is not less than 11. So I only have one true region. So I'm going to graph it on here. This is less than, not less than or equal to. So this is only parentheses, no bracket here, because it doesn't equal. And so my solutions are in between negative 9 and 2. This is the region that was true. So any number in between here, not including my boundary points. And I'll just write that answer in interval notation as well. So it's parentheses negative 9 to 2. Okay, so let's solve another one. Same way, we're going to solve and graph 3x minus 2 is greater than or equal to 8. So again, first step, we're going to write this with an equal sign. My absolute value sign is already by itself, so I'm going to set up my two equations to solve. 3x minus 2 equals 8, or 3x minus 2 can equal negative 8. I'm going to find these two solutions. In the first equation, I'm going to add 2, so I get 3x equals 10. Divide by 3, and I get 10/3, which is 3 1/3. Just helps me kind of place this on the number line if I write it as a mixed number. In the second equation, I'm going to add 2, and I get 3x equals negative 6. Divide by 3, and I get x equals negative 2. So let's do the same thing. Let's draw these on the number line. Negative 2 and 3 1/3. And again, I'm going to test a number in each one. So I'm going to test negative 3. Here I happen to have 0 again. And then in this last region, I'm going to test 4. So test all 3 of these points into the original absolute value inequality. So when I test negative 3, get 3 times negative 3 minus 2. I'm trying to see if that's greater than or equal to 8. Is it true or false? This is negative 9 minus 2, which is negative 11. Don't forget the absolute value sign. The absolute value sign of negative 11 is 11. And 11 is greater than 8, so this is true. Okay, in the middle I'm going to test 0. Plug in 0 for x. And I get 0 minus 2 is negative 2. Absolute value of negative 2 is 2. 2 is not greater than 8, so this is false. And then the last region, I'm going to test 4. So 3 times 4 minus 2, and is that greater than or equal to 8? This is 12 minus 2, which is 10. The absolute value of 10 is 10. And 10 is greater than 8, so this region is true. So in this case, I have the two outside regions as the solutions. So be careful, look at your inequality symbol. It's greater than or equal to, which means it's a bracket. And make sure you're picking your boundary point, not the point you tested. So the boundary point is negative 2, and this region was true. And then the boundary point here is 3 1/3, and this region was true. So I highlight the two outside regions. I'm going to write that answer in interval notation, reading this from left to right. So starting on the left of the number line, this is going towards negative infinity. Remember, you need a parentheses for negative infinity. And it's ending at negative 2 with a bracket. And then to show the other region, I use the union symbol to, oops. Let's see if I can, okay. I use the union symbol to show its union with this other piece, which is bracket 3 1/3. And then this goes on to infinity with the parentheses, and that's our solution.